All right, welcome to the third episode of Learning Math MCAS by Mistake. We're going to start with a really simple but important topic we did this year: linear, nonlinear, and function, not a function. So let's take a look. There's no mistake here to be had, but remember, to be a function, right? What has to be true? So I'll go over here to the side here. So to be a function, it has to be something. If you think back to the nuggetizer machine, when one x comes out, there has to be a particular, let's call it, say x comes out, x goes in, and uh, b comes out. But then let's say you do, x goes in again, and for some other reason c comes out. That is a broken machine, because whenever you get, every x is supposed to give one unique output. So this would be like xb, xc. That is not a function. Okay. All right. So that is just a review on function, not a function. So no mistake on this first one. Too easy. What is one value that could be put in for x that would make this not a function? So hopefully you can think of one value. I can think of two. There's two possible answers here that would break this machine. If you put in a 7 or a 12, the 7 or 12 will make the x repeat, not a function. All right, so the same thing here, which is not a function. Let's say you're looking at this one quickly and like, I can see this one's going to 2. That is definitely not a function, because that it can't go to 2. That would be like not a function. It'll break the machine. However, that is a math mistake there. The correct answer here is D, because if you look, sorry, I probably shouldn't have said that right away, but 3 goes to 0, and 3 also goes to 3, making the x repeat. So this one is not a function. Okay. Moving right along, we then also talked about linear and nonlinear. Okay. So I think I have a few. Yeah, there's a couple for this one. So which of the following graph shows a linear function? So we're just looking for a straight line. All right, straight line. That's a straight line. B. That's a math by mistake, MCAS by mistake question if I ever saw it. B is undefined. That is literally probably the only straight line that is not a linear function. The linear function here, that's curvy, so that's not linear. That's not linear. So the correct answer is C. Even though the slope here is 0, that still is a function. It would pass the vertical line test. I don't know why I mentioned that, but it would pass the vertical line test. All these actually are truly functions, for sure. Thought I had, I guess not. Thought I had, going back to function, not a function. That has to do with the vertical line test. I thought I had a question on that somewhere, but I might have missed it. So going back to function, not a function. Is that a function? Yes. Is that a function? No, because it would fail the vertical line test, so not a function. Neither of them are linear, so not linear, because this one, they're both curvy, but this one, again, this is not a function, because this would be at, like, I don't know, maybe this would be coordinate 2, 4, and then this would be like 2, -3. It's not a function. All right, going back to linear, nonlinear. Sorry, it's a little all over the place here. Let's see here. Okay. All right, linear, nonlinear. So we got, well, this one I won't make any mistakes. So linear, nonlinear. That is linear. That would make an exponent of 2, so that's nonlinear. That's linear. That's linear. Nonlinear, nonlinear. All right. What if I had this one here? What's my mistake here? I'm going to go, let's see. I'll just put arrows. So not linear, 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 not linear, and let's go not linear. So I made a mistake there. Maybe you thought that had a negative in it, so it would be not linear, but that one actually is indeed linear. Okay, that would just be here, here, and here, like that. That would be just a negative slope straight line. Might as well just show it to you really quick. If I was looking for representing the linears here, I think we talked about this one. X times x, for those of you that are not compacted math, that is x squared, so that makes it not linear. The only one here linear is that. Cool. All right, then we got to everyone's favorite topic, rational, irrational numbers. So classifying the numbers here. So let's take a look at this one. Which of the following is an irrational number? Okay, well, I would say if it repeats like this, that's definitely irrational, because you can't have this would just go on forever. 1.363636 forever. That's definitely irrational. Hopefully you picked up on my math by mistake there. It's actually B. B, there's square root of 3. If you did it, there is no square root of 3. It repeats with a pattern and goes on forever. That's actually the square root of 3 there. If I did this one example here, okay, that's an. I don't know if you're allowed to have it. That's got to be irrational. I don't think you're allowed to have a square root in the bottom. That's got to be irrational. But unfortunately, that's not the irrational number. The correct irrational number here, that is square root of 9 is just 3. So that's just 2/3. That's rational. That's rational because it ends. That's rational because it repeats. This is the irrational because there's no square root of 2. And even if you divide it by 9, it's still irrational. All right, let's estimate some of these square roots, shall we? So square root of 11, too easy. So square root of 11 is between square root of 9, square root of 16. So it's between 3 and 4. So it's got to be, there's my 3 and 4. It's got to be A. That's a math by mistake there. It's definitely not between 3. It is between 3 and 4. That part hasn't changed. But if we were between square root of 9 and square root of 16, right, you can see it's definitely closer to 3 than it is to 4. So I would say it tricked you if you did that one. It's this one here, B. Okay, let's go on to another one. Okay, square root of 8. Okay, that's between square root of 9, square root of 4. So it's between 2 and 3. So let's go with A. It's a math by mistake. Think about which one it's closer to. It's definitely closer to 9. So the correct answer, square root of 9, which is 3, that's closer to 2. So the correct answer is actually B. So it's about 2.5 to 3. So because it's right over here, closer to this, like that. Okay, moving right along. Pythagorean theorem. Okay. Let's do this one. Okay. So it's been sitting in front of my classroom, but let's just pretend you did this one incorrectly. You're like, all right, Pythagorean theorem: a squared plus b squared equals c squared. 6 squared plus 10 squared equals c squared. So this one's going to be 36 plus 100 equals c squared. I can't continue to make this mistake. We already know that I set this up wrong because the hypotenuse is 10, and that goes out there. So the correct way to do this is 6 squared plus b squared equals the hypotenuse squared. So 36 plus b squared equals 100 minus 36. B squared equals 49. Square root. You get B. I'm sorry. That was an unintentional math by mistake here. What's 100 minus 36? 64. So then you get 8. So, of course, 6, 8, 10, I threw it back again. That's that one. Again, they come up a lot in MCAS 6, 8, 10, and all the ones that went along with that fish song there. This one, if I was to set this one up correctly, just to show it to you here, this one is a missing hypotenuse, this diagonal, so it would be 15 squared plus 20 squared equals c squared, and then I would just go through and solve for that. All right, let's do a mistake on this next one here. Here. All right, so say you're like looking at this and you don't even notice this Pythagorean theorem, and it wants to know the distance from t to u. So, all right, here we go. 1, 2, 3, 4, 5, 6, maybe 7. I'm going to put 7. But that's incorrect because I got to do the Pythagorean theorem for this. So the correct way to do this is here and here, make a right triangle. I already counted this out ahead of time. It's a 6 by 7. So 6 squared plus 7 squared equals c squared. So you get 36 plus 49 equals c squared. 36 plus 49 is 85. I know that's really darn close to 9. Sorry if you can see that. So the answer here is 9. All right, moving right along. Volume. Okay, cone. Let's do it. So you have the formulas, the cone formula. Let's say you're going through it. You're like, all right, pi r squared times height. Okay, let's do, and then divide by 3. Okay. All right, let's do here. So we go pi 10 squared times 18 divided by 3. So that's going to be, I can do that in my calculator, 100 times 18 divided by 3. Oh, 600 pi. Answer 600 pi. Notice it's in terms of pi, so I did not change pi to 3.14. Looks good to me. Anyone see a math by mistake? Hopefully you do. I used the wrong radius. The radius is not 10, the radius is 5, so it's pi 5 squared times 18 divided by 3. That's going to be 25 times 18 divided by 3. So that's going to give me 25 times 18 divided by 3. The answer is 150 pi. So hopefully you caught that mistake. I think in episode 1 I talked about a question, a story graph. This is kind of the one I was thinking about. So I actually got a mistake on this one. I couldn't find the right answer the first time I was looking at it. I'm like, all right, so paddled for 100 minutes. So we're looking at time and how much distance was covered. So I'm like, oh, it looks like she paddled for 100 minutes. It looks like she paddled a total distance of, total distance of 3 kilometers. Okay, that kind of, well, no, that one I know is wrong. Because, like, you go 3 kilometers and then 3 kilometers back, because Mia paddled her canoe from shore of a lake on an island, stopped, have lunch, and then paddled back. So it's not that one. She paddled more than 3. Mia paddled faster on the way to the island. On the way back, well, I'm like, no. It doesn't. It looked like she paddled. You can see here the slope's just a little bit steeper here. The slope here is up 3 over 40. And then here, you can just see this is a little steeper. So she actually paddled faster on the way back. But what's wrong here? Why isn't it A? I couldn't figure it out. Because she didn't paddle for 100 minutes. Because if you look, when she gets here, from 40 minutes to 80 minutes, her distance is not changing. So she's not paddling here. She's having lunch. So she didn't paddle all 100 minutes. So the correct answer is she paddled on the way back. Mia paddled faster on the way back. This is her way back. It's a little bit steeper. And again, if I go back to the slope, it's down 3 over, so goes 10, 20, so over 30. 10, 20, 30. So that's a faster, even though it's a negative rate, that's actually faster. So I would say D for that one. Okay. Now we're going on to stuff that we haven't learned yet if you're watching this after April vacation. But I wanted to throw these in here because we're going to either learn them in more detail after vacation, after MCAS, or right before MCAS. So this is called a scatter plot. And a scatter plot is exactly what it sounds like. It's a bunch of plots scattered along, and you're trying to put a line of best fit. So if you look at this and you're like, all right, what's the most appropriate line of best fit? You're like, oh, that looks pretty good. They're all above it. The answer is A. But that's a math by mistake. There's no way that's the line of best fit. You can see that D is a much better line of best fit here. So you want to have about the same amount of points above, the same amount of points below. If there was a point here, actually I'll cover that one in red. This is called an outlier. Just like in Sesame Street, it's not like the others. This would be a coordinate 1, 3. It is way farther than the rest of the data. That is considered an outlier. We're going to do a really good MCAS question before MCAS that kind of talks more about making predictions with these answers and actually coming up with the, like if I wrote the equation to this one, let's just roughly say, yeah, it definitely would be like y equals, let's say it started at 0 and then it went up 1 over 1. So maybe y equals 1x, to be a little boring there for that. All right, almost done. Then we got, let's call it a two-way table. It says we got left-handed people and right-handed and what kind of movies they prefer. So let's say it says here, what is the relative frequency of left-handed people prefer comedies to all the people that prefer comedies? All right, too easy. Left-handed people prefer comedies to all the people that prefer comedies. That's going to be C. I'll put that here. 35 over 70. That's a math by mistake. If you look, it says to all the people that prefer comedies. So it is 35, but how many people really prefer comedies? It's both these numbers. So it would be 305, which would make it B. And then because this is 305, they don't sometimes, this would be 195. This one goes across, so all the left-handed people would be 5, 40, 50. And then I would add those two to people, get all the right-handed people. So that's a little bit of a two-way table. Then we have, this one already has a mistake done. We'll talk about this hopefully before MCAS. This is your exponent rules, okay? All right, so let's say, how can I make this mistake? And I get 160. All right, let's see if I do this here. So power to a power, I just add. So I get 5, 2 to the 5th. Okay, 2 to the 5th is 2 times 2 times 2 times 2 times 2, just 32 times 5. It's got to be B. But I made a mistake on purpose there. Hopefully by now, you know its power to a power is multiply. 2 times 3 is 6. So 2 to the 6 is actually 64. And 64 times 5 is actually 320. Last couple questions. I want to wrap this up in 3 episodes here. So here's the last couple. So let's say there's a mistake here. This is called scientific notation. So if you look here, you're like, all right, -6. I'm looking for the choice that has 6 digits. So it's got to be 1, 2, 3, 4, 5, 6. That has, okay. Spoiler alert, this part's called the mantissa. It's got to be between 1 and 10. So I'm going to put B. That's actually super wrong. We're actually looking for the -6 tells us how many places to move the decimal left. So when you go left 6 places, that's left 5 places, but this is left 6 places, and it gives you 1, 2, 3, 4, 5 zeros. Because the mantissa that has 1 place, that 5 doesn't get a 0. That 5, when you move it over, it's just like 1. There's no 0 there, but then there's 5 zeros for that. So that's the correct answer. Scientific notation. Let's see here. Almost done. Hey, I don't know if you're gonna get this far before MCAS, but let's give it a shot. So let's see. Multiply this 5 times 10 to the 3rd to get this. Okay. Well, let's just say, okay, if we want to get this to this, maybe we add 3 to that to get 3 plus 3 is 6, so it's A. Not exactly. This might be above our head before MCAS, but we'll try it anyways. So you want to do 5 times 10 to the third, and you want that to go up 3. But if you go here, times 10 to the third again, like bases, that does make it 10 to the sixth. So what was that like thing that I added, that I multiplied by, was 10 to the third. 10 times 10 times 10. 10 times 10 times 10 is 1,000. The correct answer was C. Wrapping up scientific notation and MCAS by mistake, episode 3. Let's take a look at this one here. Okay, so let's try this one. So we're looking for, whoa, this is going to be a huge number. Okay, maybe it's the number of zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's got to be D. It's got 11 zeros, right? And math by mistake, that tells you how many places to move it to the right. So when you move it to the right, 11 places, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. How many zeros was that? 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. Correct answer there is B. So that was the entire 8th grade school year and 3 episodes of math MCAS by mistake. Hopefully that helps you study and prepare and review and do awesome and get those meeting expectations, exceeding expectations, and those SGPs above 50%.